The setup inside 12D is the same for HEC RAS as it is for xpswmm. So if we're going to be exporting to the xpswmm or Storm programs, we move up to Design, down to Rivers, and select our xpswmm interface. Now the first thing we'll do is select the Create XPX file, and you'll notice that all of the model and settings are essentially the same for both programs. Down to the xpswmm, 12D has the capability to launch the XP program, and to do that it needs to know where the executable is. So we'll do a bit of a browse to find this executable. Where it is, first of all, is on drive C. Generally it's in the XPS software folder, xpswmm, and in our case we have both a hardware and software protected version. You'll be looking for the xpswmm with the P. Now it also means that it is going to create this hydro.ini. That's the startup file for automatically launching SWMM. But when it writes out an XPX file, it will also put it into this working folder. So we'll select and finish. Now you only have to do that once, and those settings will be stored for all of your 12D exports. Now we do need an XPX file name, so we'll call this Geelong, and then select Process. And it tells you to make sure SWMM's not running so that it won't accidentally launch two models. Now here's where you get the choice of launching xpswmm and using a template called masterrivers.xp, or you can just create the XPX file and do everything manually. And that's what we're going to do. We'll do it manually. So we'll select Create the XPS, Process, and it's finished. Once inside xpswmm, the first thing you're presented with is the Create project. So we're going to create from a template. Now it's taken us into the work folder, and we're going to call it 12D Rivers. Select the Enter, and it asks for the template. For this one, we're going to use the metric template. Now that we've created the project, we're ready to go read that XPX file. So File, Import Data, Import XPX. Hit the Select button. It's left us in the Templates folder, so we'll have to move back up and go into the Work folder. And there's our Geelong.xpx file. We'll go import that. Gives us a warning telling us that there's no undo. And here we have our folder, our project. You'll notice first of all is that when 12D creates the sections, it creates a link with the L in front of it, and it also creates a node. So each one of our sections has now become a link inside XP. Now let's double click on one of those and take a look at this from our conduit profile. What it's done is it's gone and measured the center line length along the center line of the string. It's gone and measured a downstream and an upstream invert. Now these inverts have come from the lowest levels on the cross sections that have been cut. If we want to take a look at what that cross section looks like, let's go into the natural section box and take a look at the section that 12D created. Now it's called natural section and L-120 because it is section 120 inside 12D. If we select Edit for that, you'll see that it's marked both the left and the right bank markers for us. We've got our data. We've got the N values from our startup box. And so it's pretty well ready to go. The other thing you'll notice is that there's once again a left, a center, and a right bank distances. The reason that this one has a maximum depth of 0 is that's the code to XP to tell it to automatically calculate the full height of the cross sections. If we go up to the very top section, you'll see that it has a discharge in it. If we take a look at our inflow, it's set at 10 qmix. That came from the startup dialog. Also, if we take a look at the very last one, it's been marked as an outfall, and at this outfall it's been marked as a free outfall from the system. Now once again, those are the default conditions, but of course you're more than welcome to change those inside XP. Now when you're ready to run this program, you move up to the Solve button, select Solve, and it'll come back and tell you if there's any errors or any warnings involved. First of all, we have a couple warnings telling us that the conduit length is less than the minimum length in the system. Now that's a standard message from XP. indicating that the sections are less than 10 meters long. Now it'll still run, that's just a warning, but it has given us an error telling us that there are no subcatchments. Now the reason for that is that if we moved into our runoff and then went to our job control, you'd see inside global storms it's been set to run 3 global storms, and we have not done any hydrology work at all. So we'd like to tell XP not to run any hydrology. To do that, we're going to go to Configuration, Mode Properties, turn off the runoff so that all it calculates is hydraulics. Selecting OK for that, let's return to our hydraulics mode and select Solve. Okay, we've got one other error message. It tells us that there's no interface file. Well, that one we can fix up pretty quick. Configuration down to interface files, and we'll make sure we turn off that interface file because it's not being used. Now those 2 settings that we changed, the global storm, the configuration mode properties and the interface files, if we stored those settings inside the template, we wouldn't have to do it at the start of the job. So now we'll move up and we'll go run this again. And you'll see there's a couple warnings inside there, but essentially it's ready to go. Now one last item, you'll notice it's trying to run 3 separate jobs. If we run global storms inside XP, it will not, currently at version 10.52, it will not export any results back to 12D. So it's important that we turn off those global storms. Going to runoff, once again back to job control. All we have to do is turn off that tick box and all is well. So once again, let's go back to hydraulics, just so we can see what we're running, and select the run button. And this time you'll notice all's good. Close that, it's ready to run, and solve that. And you can see what it's done is it's run that first bit of results. Now if we'd like to see what kind of water levels have resulted, we can select the first one, hold the shift key, pick the downstream end, and to look at everything that's been calculated, we're going to these dynamic section views. Now we've selected quite a few different views here, but what you can see is, first of all, you can see the water levels at the start of the project, and you can see our hydrograph ramping up from 0 to the full 10 cumex that we specified. Going up here and stepping through this, you can see that wave of water moving down through the river till eventually we reach a steady state condition. And that steady state condition, the final results, are what we want to export back to 12D. Now if we had a hydrograph that was running up to a peak and back down, it's truly the peak results, not the end of the run results, that get exported. So it's the peak that we are looking for. Now to export this data back to 12D, we have to go File, Import Export, and select Export XPX Data. Now we want to export the nodes and the links, and we might as well export all variables. It's the easiest thing to do, and 12D will sort through that data looking for the results. Selecting Export, it once again takes us back to the work folder, only you'll notice that it's changed the name of the XPX file to the name of the project. So we'll have to go looking for this file when we're back inside 12D. Selecting Save, those results are exported, and now we're ready to go back to 12D to look at the results. Now that we've exported that XPX file from xpswmm, we're ready to read those results back into 12D. We'll go up to our rivers once again, Design, Rivers, xpswmm interface, and read the xpswmm results. Now essentially we have exactly the same models as we had for our HEC RAS interface, except we have the one extra option to choose the link methods to talk to XP. Your 2 choices are to use the node names or node coordinates. If you haven't renamed, then you might as well use your node names. However, if you have gone and changed your names inside xpswmm, then you would want to do the link via the coordinates. Now the results file, we're going to have to browse to that one because we've changed it from the Geelong to the 12D rivers. So drive C, we're going to move to our xpswmm folder, XP software, xpswmm work folder, and that's where we're going to find our results 12D rivers file. Now we're going to create some new water levels, so we'll call these water levels XP, and a new water surface, so we'll call that water surface XP, and some boundary strings, we'll call that boundary strings XP. Once again, the same chord length. It does have the other option. When it does this node name comparison, if the node names can be converted to chainages, it will do a comparison by looking at the tolerance being closer than, in this case, less than a millimeter. Now, usually the tolerance isn't required, because if you haven't renamed them, the names will be exactly the same, and you will get an exact match. So let's select Process for that. And you can see it's imported the results. So we'll go up to our plan view, and we'll turn off all those existing models. And we'll come on and we'll add on our water levels XP. And you can see essentially, once again, we have this 2D strings with our water level results. And then if we come up and add on our boundary strings, we've got our XP boundary strings here. And you take a look. One thing you'll notice is that the island at the downstream end has disappeared. The one difference that we had between our 12D and our XP run was that when we did the XP, it started as a free outfall. When we started the HEC RAS run, we started it as a normal depth at the downstream end.